You're welcome to my channel. Today I'll be presenting on multiplexers and decoders. And one would ask, what is a multiplexer and what is a decoder? And so a multiplexer is um, a, a circuit which actually has inputs and it gives you expected outputs based on a select signal, whereas a decoder has inputs and gives you multiple outputs. So based on a select signal as well. So what we will be doing today is I'll illustrate the 2-in-1 multiplexer, 4-in-1 multiplexer, 8-in-1 multiplexer, 16-in-1 multiplexer. And I'll also illustrate what the 2 to 4 output multiplexer is, 3 to 8 output multiplexer decoder is, sorry, and then the 4 to 16 output decoder is. And so as you can see here, we have all of them here, and these are the representation. And so with the 2-in-1 multiplexer, what we have is that we've simplified it using the KMO. And these are the select signals, and these are the inputs, yeah, and this is the expected output, and then these are the select signals. And so when you have a select signal of 0, it gives you an output of D2. And then when you have a select signal of 1, it gives you an output of actually D1. And so we've simplified this using the KMOS. And as you can see here, we have D1, we have D1 to, I'm supposed to be D0 and then D1. So we have D1 to D2 here. And then we have the select signal as well. And so this is the simplified equation for the 2-in-1 multiplexer. And so let's see how it's being represented in Logisim. And so this is it. And so we have the select signals, and then we have the basic inputs, which are D0 and D1. And as you can see, when the select signal is 0, D1, we get the output of D1. And when the select signal is 1, and D1 is selected, we get an output. And so that is the 2-in-1 multiplexer. Now let's move on to the 4-in-1 multiplexer. With the 4-in-1 multiplexer, we will implement an AND gate using the various minterms, and then the minterms will serve as the output, as the input. So we have D0, D1, D2, and D3, and then we have the select signals of S1, S2. And so when the select signal is 0, 0, we get an output of 0. When the select signal is 0, and then select signal 1 is 0, and then select signal 2 is 1, we get an output of 0. And so as you can see here, if we have 4 inputs, we get 2 select signals. And how did we come about that? And so if you have inputs and then you want to know the select signals, we use the log2 of the inputs that we have. And so this one we have 4 inputs, and so we should, if you want to get the select signal, we get log2 4, log2 4. That is a 4. So we have log to the base 2 4, okay, which gives you 2. And so that's how come we have the 2 select signals here. So when we do the calculation, we actually get it. And so it's to get the select signal is equal to log to the base 2, log to the base 2, okay, times the number of inputs to get your select signal. And that's how come we have 2 here. So we have 8 inputs. How many select signals will we get? And so log to the base 2, 8. So log to the base 2, 8 gives us 3 select signals. Actually give us 3 selected signals. And that's what we use for the 81 multiplexer as well. And so for the 4, let's see how we implement the AND gate. So this is a 4-in-1 multiplexer. And as you can see, you have the select signals here. And so we will, let's see how it works. So let's see. So the various inputs are, so when we want D1, to be able to get D1, so if D1 is 0, and all the select signals, so if you have all the select signals are selected for now, and so this one, we get 0, get this one, get this. So it's only D3. When D3 is 1, that's when we get an output. And as you can see, you have an output of 1 here. And so this is actually how the AND gate is going to represented with the 4-in-1 multiplexer. Okay. So all the other inputs will not, you get 0, you won't get any output. But immediately you get, yeah. So if all of them are 0, and then you have this, you get your output. Okay, so let's see the 81 multiplexer. So this is actually the 81 multiplexer. And so we have 8 inputs and then 3 select signals. And I said that to be able to get the select signals, you have log to the base 2, and then the number of inputs that we have. And so this one we have 8 inputs. So log to the base 2, 8, and which gives you 3. And so you can see all of them here. And so let's see how this one is also represented in Logisim. Okay, so this is it. So you can actually see, let me minimize this. Let's see what's the results. Okay, so this is a representation of the 81 multiplexer. And so when it is 1, we get an output. Okay, when we select D1, we get an output of 1. And as you can see, we have an output of 1. You can see the output is here. And I will select D2. Oh, sorry. These are supposed to be D0 to D7. They're supposed to be D0 to D7. And so there's some small issue here. But that's not an issue. It's just a naming convention. And then we've actually exceeded by 1. So that's not a problem. And so we can even change it. Let me change it myself. So it's supposed to be D0, D1. So, okay, so it's done. So we select, let's simulate it. So we select D1. We don't get any output. You can see, we don't get any output. So we select D1, we don't get any output. We select D2, we don't get any output. We select D3, we get an output of 1. 4, we get an output of 1. D5, we get an output of 1. D6, you don't get any output. And then D7 is also 0. And so as you can see, there are some inverters here. And that helps us with actually getting all the output here. So you can just take a picture of it or have a look at it and then just build it yourself. It's better when you build it yourself. So that one actually helps. So let's look at the system in one multiplexer. So this is the system in one multiplexer. And with the system one multiplexer, we are using the min terms to select. And so when it's 000, okay, we get D1. D1 will select, and when it is 0001, we get this. And so that's how we will be able to work with the system one multiplexer. And so this is how the system one multiplexer is. And so with all the select signals, let's see. So we have this, and so this one selected, this one selected, this selected, this selected, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, 13, 14, and then the last one is system. So this is a system one multiplexer. And so with the help of the inverters, they are able to give you the expected output, because when you take out the inverters, some of the outputs, you don't actually get the output. And so the inverters actually help. It's just that we have a lot of gates here. And that will be very costly if you have to implement this, because of the cost involved in some of the gates. So this uses a lot of hardware compared to you simplifying it with a K-map. And I came up with system inputs is also very difficult, but then we've been able to do it. So let's move on to the 2 to 4 output decoder. And so with the decoder, you have your inputs, and then you get your output. And so these are your inputs, and then you have your output. And so to be able to get Y0, it should be 00. To be able to get Y0, it should be 00. And so it's 00. That's when you're able to get Y1, Y0. Okay. To be able to get Y1, you should get 01. So to be able to get Y2, you should get 10. So 10, that's Y2. And then to be able to get Y3, you should be able to get 11. And so this is it. Our same thing applies to the 3 to 8 output decoder. And so for that one, Y0 is when all the select signals are 000. And so if we get Y1, we need to get this select signal should there. If you want to get Y2, how to get this? If you want to get Y3, you get this. If you want to get Y4, you get this. If you want to get Y5, you get this. If you want to get Y6, you get this. If you want to get Y7, you have to get this. So this is a 3 to 8 output decoder. Now let's see the 4 to 16 output decoder. And so if you want to get Y0, you, all the SLS signals should be 0. All the input should be 0. And so that it gives you Y0. And so if you want to get Y1, A1 has to be selected, Y2, Y3 should be this, Y4 should be this, Y5, Y6, Y7, Y8, Y9, Y10, Y10 is this, Y11, Y12, Y13, Y14, and then Y15. And so there's a demonstration of what the multiplexer is and then what the decoders are. And so you have to get to know that in order for you to get your select signals, you need to get log 2 to the log base 2 to the input for the multiplexer. And if you want to get your output for the decoder, that is 2 raised to the power the number of inputs. And so for the decoder 2, so the 2 to the output for decoder. So we have input of 2, and so 2 to, so 2 raised to the power 2, which is equal to 2 times 2, it gives you 4. Okay, so that is it. So that's it for today. You can implement this yourself and don't be scared. You just do what's step by step, and I think that you'll be able to come up with a solution to it. Okay, thank you very much.